Hello everyone, welcome to the lesson of Edexcel IAS Network Transmission Media. To start off with, let's discuss what a transmission medium is. In network communications, a transmission medium is a physical connection or an interface between the transmitter and the receiver. Next, let us see the key characteristics of the network media. Uh, a suitable medium typically provides good quality communication at long distances, and then it ensures a higher data rate at long communication distances at a lower cost. The three factors affect the maximum communication distance and the maximum data rate of a medium is the interference, communication bandwidth of the medium, the transmission impairments occurs when the received signal is different from the transmitted signal. The interference is, there are some new words, so we'll see what those are. The interference is the distortion of the signal in the transmission due to unwanted signals from outside sources, noises, and all that. The bandwidth of the medium determines the signal frequencies. That is, it determines how much data can be transmitted at a given instance. And then transmission impairments. Those occur when the received signal is different from the transmitted signal. The transmission impairments include noises and distortion during the transmission. If we look at the types of transmission media, there are two main types of transmission media, the guided media and the unguided media. Guided media is where the waves are guided along a solid medium, such as a transmission line, uh, and you have a physical transmission medium. Unguided media means transmission and reception are achieved by means of an antenna. We find types of guided media, which are coaxial cables, fiber optics, uh, twisted, strip line, and microstrip line. Under unguided media, we learn three types of unguided media, which are radio waves, microwaves, and infrared. The guided media, also known as wired or bounded media, consist of wires through which the data is transferred. It's a physical link between the transmitter and the recipient devices. Guided media is a physical link between the transmitter and the recipient devices, as I mentioned, and in these signals are directed in a narrow pathway using the physical links. These media types are typically used for shorter distances where you can physically lay the cables and etc. As I mentioned before, there are five types of guided media that we are going to learn. Um, they are, yeah, you can see what are the five things that we are going to learn: coaxial cable, twisted pair cables, fiber optic cables, strip line, and microstrip line. Okay, let's first learn about the coaxial cables. Coaxial cables contain an insulation layer to protect it from noise and distortions. I have underlined in red in the screen the insulator. You can see its insulator is covered. That is the protected layer, and it transmits information in baseband mode and broadband mode. Coaxial cables are made of PVC or Teflon and contain two parallel conductors that are separately insulated. And these cables can carry high frequency electric signals without any big data loss. The advantages of coaxial cables include they provides high bandwidth, better noise immunity because it's insulation layers, and it's easy to install and expand whenever we want, and also these cables are not expensive. But it has some disadvantages as well. Um, If a signal cable fails, it can disrupt the entire network because you have the cable, and if there's a disruption or some broken areas, the entire connection is not working. That is a drawback. Now we talk about twisted pair cables. Uh, as the diagram shows, two insulated conductors of a single circuit are twisted together to improve electromagnetic compatibility. See in the first top diagram, you can see uh, two are twisted together. A single cable has four pairs of such twisted pairs, so it's totaling to eight cables. Look at the first diagram. You can see there are two wires twisted, and there are four such wires. So altogether, there are eight cables inside the twisted pair cables. So this is the most widely used transmission medium cables. These four pairs are again packed together in protective sheath. You can see there's a wide protective sheath. Twisted pair cables come in different speeds and are rated by category that determines the maximum speed it can operate in. For an example, there are category 5 and category 6 cables that those are marked depending on the speed that they support. Uh, The twisted pair can be further broken down into two subtypes. They are the unshielded twisted pair, or we call as UTP for short, and then we have shielded twisted pair, or STP for short. We will see next what UTP and STP are. Before that, please look at the two diagrams in the screen. The unshielded twisted pair in the first diagram, and in the second, the shielded twisted pair where you can see a shield uh, around the twisted cables. Okay, the unshielded twisted pair, the UTP, is used in computer and telecommunication mediums. Its frequency range is suitable for transmitting both voice and data. It is widely used in the telephone, computers, and etc. It's a wire with no additional shielding to protect its data from the exterior. That is the main difference between UTP and STP. Therefore, it is cheaper than the shielded twisted pair because there's no additional protective cover. Uh, since it's cheap, yet no shield against noise, it is commonly used for LAN networking. Advantages of UTPs, it's less costly as I mentioned before and less expensive, unshielded wire from another network medium, and it is designed to reduce crosstalk, RFI and EMI. We will talk about RFI and EMI next. Its size is small and hence the installation of the UTP is easier. So yeah, EMI is its EMI stands for electromagnetic interference, and RFI is radio frequency interference. So EMI and RFI are two types of interferences. So those are disturbances. The interferences are disturbances generated by external sources that impact a cable by degrading the performance or completely preventing it from functioning. Another point is it's mostly useful for short distance network connections like home and small offices and organizations. And it is the most commonly used networking cable in the market. It's less costly, as I mentioned. It is considered as faster copper based data transmission cable and suitable for transmitting both data and voice. Right. So we talked about the advantages. Next, we'll see what are the disadvantages of using unshielded twisted pair. It's limited length segment up to like 100 meters, and then UTP cables are commonly used for Ethernet connections, and they have a maximum recommended cable length of 100 meters. So this limitation is due to signal attenuation, which means that as the signal travels along the cable, it gradually loses the strength. So the longer the cable, the attenuation is high. So beyond 100 meters, the signal may degrade to the point where reliable data transmission is not possible. To cover longer distances, additional networking equipment like switches or repeaters may be used to extend the reach of the network. The second drawback is the limited bandwidth. UTP cable come in various categories such as Cat 5, 6, and each with different levels of performances and bandwidth. While newer categories of a higher bandwidth, all UTP cables have a limit on the amount of data they can transmit. For example, Cat5 cables typically support up to 1 Gbps, 1 gigabit per second of data transfer, while Cat6 could handle up to 10 Gbps. So, but however, when we compare to other types of cables like fiber optic, UTP cables generally have a lower bandwidth capability, so that's a disadvantage. The third disadvantage is lack of inherent security. UTP cables don't provide inherent security for data transmitted over the network. They are primarily designed for physical connectivity and electrical signal transmission. This means that data transmitted over UTP cable is vulnerable to uh, interception if not properly secured through encryption and network security protocols. To ensure secure data transmission, additional security measures such as virtual private network, VPNs, firewalls, and encryption should be implemented at the network and applications level. So it's important to note that UTP cables are widely used in networking due to their cost, effectiveness, and ease of installation. However, there are limitations as outlined in now. So make them use suitable for specific applications and within certain distance constraints. For longer distances or higher bandwidth requirements or high security requirements, UTP is not suitable. Okay, now we talked about UTP and now we are going to talk about STP, where it has a shielded twisted pair. So, shielded twisted pair is a type of copper cabling commonly used in networking and telecommunications. And it shares, look at these diagrams as well because it has the proper diagrams for these types. You can see a shield around these twisted pair cables. It shares many similarities with the unshielded twisted pair, but includes an additional shielding layer to protect against electromagnetic interferences, EMI, and radio frequency interferences, RFI. STP is usually used underground and therefore it is more costly than UTP. Unlike UTP, STP supports the higher data transmission rates across long distance. You can remember we discussed the disadvantages. We cannot have long distances connections and low bandwidth with the UTP, but with STP it supports higher data transmission rates and also longer distances. Okay, so advantages of STP, lower noise and attenuation. We mentioned that there's attenuation which is degrading the signal strength uh, along the cable, but with STP it's lower than UTP. And STP cables are shielded with a metal layer that helps reduce electromagnetic interference, the EMI, and radio frequency interference, RFI. So this shielding results in lower levels of noise and attenuation in the cable. Noise refers to unwanted electrical signals that can disrupt data transmission, and attenuation is the gradual loss of signal strength as it travels along the cable. STP shielding helps maintain signal integrity by minimizing both noise and attenuation, leading to more reliable data transmission. Number two, protection from harsh environments. The plastic cover or the outer jacket of STP cable provide an additional layer of protection. So this means the outer covering shields the internal twisted pairs and the shielding layer from physical damage and exposure to harsh environment conditions. So this protection is particularly valuable in industrial or outdoor settings where cables may be subjected to moisture, dust, or mechanical stress. The plastic cover also contributes to the improved data transmission rates by preserving the integrity of the cable. The third advantage is reduced crosstalk and external interference. The STP cables are designed to minimize crosstalk, which occurs when signals from one twisted pair interfere with signals on adjacent pairs. So, the shielding in STP cables significantly reduce the risk of crosstalk, resulting in clear and more reliable data transmission. Additionally, the shielding provides a barrier against external interference. Sources such as electrical equipment or nearby cables, further enhancing the cable's resistance to interference. The fourth advantage is modular connection for termination. STP cables typically use modular connectors, commonly RJ45 connectors for termination. These connectors are standardized and easy to work with, allowing for straightforward and secure termination of the cable. The use of modular connectors simplifies the installation and make it easier to connect STP cables to network equipment such as switches, routers, or computers. And these advantages collectively make STP cables a preferred choice in environments where noise, interference, and signal quality are high. Right. But we also have disadvantages of STP. Mainly, the STP is expensive. STP cables are generally the most expensive type of twisted pair cables compared to unshielded twisted pair cables. The additional cost is primarily due to the shielding materials and the manufacturing process required to create the shielding layer. This higher cost can be a significant factor for organizations with tight budgets, especially for large scale network installations. Secondly, STP needs more maintenance requirements. STP cables require more maintenance compared to UTP cables to reduce the loss of data signals. This is because the shielding in STP cables, while effective at reducing interference, can be susceptible to wear and tear over time. The shielding must be properly maintained to ensure its effectiveness in protecting against electromagnetic interference (EMI), and also a regular inspection, grounding checks, and cable management are essential to keep STP cables in optimal condition. Another drawback is limited cable length improvement. Despite the presence of shielding, STP cables do not offer a significant improvement in cable length compared to UTP cables. Both UTP and STP cables typically have a maximum recommended cable length of 100 meters for Ethernet applications. While the shielding in STP cables can help with interference, it doesn't inherently extend the cable's reach beyond the standard length limitation. Even though the attenuation is low, still the standard length limitation is there. To cover longer distances, additional networking equipment like switches or repeaters is still required. The fourth disadvantage is grounding requirement. STP cables must be properly grounded to function effectively. The shielding layer, which provides protection against electromagnetic interference, needs to be connected to a ground reference point. In some cases, improper grounding can lead to problems, including ground loops or interference. So grounding also adds up some cost. Okay, this is a comparison between UTP and STP using the things that we have learned so far. UTP is an unshielded twisted pair. STP is a shielded twisted pair. UTP is a twisted pair cable with wires that are twisted together, whereas STP is enclosed within a foil or mesh shield. The price of UTP is low as compared to STP. The price of STP is much costlier than UTP. UTP has high crosstalk. STP has low crosstalk. UTP doesn't require much maintenance, whereas STP requires some more maintenance. And UTP cables are noisier. STP cables are less noisy. UTP doesn't require a grounding cable, whereas STP requires a grounding cable. Okay. Our next category is optical fiber cables. We talked about coaxial cables and twisted pair, and the third category under guided media is optical fiber cables. We also call this as optical cables. Is a type of high capacity, high speed transmission medium used for data, voice, and video communication. These are thin strands of glass that guide light along their length. They rely on the transmission of light pulses to carry information over long distances with minimal signal loss. And these optical cables can carry huge amounts of data. They have less maintenance cost, and these can be unidirectional as well as bidirectional in nature. Okay. The last category of guided media is strip line and microstrip line. So in this picture, you can see an example of both microstrip and uh, strip line layer configurations. Microstrip is the configuration used for signal routing on an exterior layer of the circuit board, while strip line is embedded within the board layer stack up. Strip line is a type of transmission line where a conductor, typically a strip of metal, for an example, copper, is sandwiched between two parallel layers, and this creates a closed, controlled path for the electromagnetic waves to propagate. Microstrip lines and strip lines are widely used in various electrical and electronic applications, especially in solid state microwave systems. With this, we conclude the guided media. Next, we will move on to unguided transmission media. Okay, so under transmission media classification, now we have completed the guided media. According to that diagram, you can see that the top part is done. So the next part we will be moving on to unguided transmission media such as radio waves, microwaves, and infrared. Unguided transmission media is also known as unbounded or wireless media, and they help in transmitting electromagnetic signals without using a physical medium. Here, the air is the acting as the medium. There's no physical connectivity between the transmitter and the receiver, and these types of transmission media are used for longer distances where the cabling is difficult, and however, they are less secure than the guided media. And there are three main types of wireless transmission media, as mentioned in the previous diagram: radio waves, microwaves, infrared. Yeah, these are the three unguided media: radio waves, microwaves, and the infrared. Okay, the first unguided transmission media type we learn is radio waves. Radio waves are transmitted in every direction throughout free space. Since these are omnidirectional, send waves can be received by any antenna. And these waves are useful when the data is to multicasted from one sender to multiple receivers. uh, Radios can cover large areas and even penetrate obstacles such as buildings and walls. The frequency of these waves ranges between 3 kilohertz to 1 gigahertz. Due to its omnidirectional nature, issues such as interference might arise when another signal with the same bandwidth or frequency is sent. And radio waves are used in AM and FM radio, and codeless phones are examples. Right. The next unguided media type is microwaves. And for these waves, it is important for the transmitter and the receiver antenna to be aligned. This is why it is known as line of sight transmission. Due to this, they are suitable for shorter distances. They comprise of electromagnetic waves with frequencies ranging between 1 to 300 gigahertz. Microwaves provide a bandwidth between the range of 1 to 10 mbps. Distance covered by the signal is proportional to the height of the antenna. For traveling to longer distances, the height of the tower should be increased. Okay, the third category is infrared. Infrared waves with frequencies from 300 gigahertz to 400 gigahertz can be used for short distance communication in a closed area using line of sight propagation. They cannot penetrate through the mm, barriers such as buildings or anything that intersect between the systems, and these are considered as one of the most secure transmission modes due to the short range. Infrared is the examples are in TV remotes, wireless speakers, automatic doors, printers, remote controls, wireless mouse, keyboards, and other handheld devices. So, with this, we are done learning on unguided transmission media. So, let's see a summarized note of what we have learned today. I'm sure these notes will help you, will be useful for your studying and also for your exams. Okay, here I have this short note for all transmission media that we have learned with under guided transmission media and unguided transmission media, and you can see the advantages and disadvantages listed against all these types. So this table will help you to answer some of the 2 marker and 3 marker questions you will be asked in the exam. So please take your time and read and familiarize. This is another short note of applications of transmission media in various types of networks. So this will help you to figure out when you get a questions on what media is suitable for different scenario. In the questions you are getting a scenario and they will be asking what medium is uh, recommended. You have to give the reasons and give your answer. So please learn this as well. So yeah, okay guys, so we are done with transmission media lesson, and so until next lesson, thank you and good luck.